Okay guys, in part 2, we're going to be measuring for accuracy using our horizon line, our baseline, and trying to measure out everything in millimeters. And as soon as we do this, we'll be able to convert these measurements into a larger building for our final drawing. Now I just measured 123 millimeters to the top of the building. So I just measured that corner right up to there from my horizon line as my start measurement of the height of the building. Next, as you can see, I've measured and already have measured my distance from vanishing point 1 to vanishing point 2. Those measurements are important. So you can see there's 152 millimeters to my left vanishing point, or vanishing point 1, and 96 millimeters to vanishing point 2 from my baseline. Now I'm going to measure from my baseline to the left side of the building, and I get a measurement of 45 millimeters. And all of this will play a bigger role in it will help us do the math whenever we have to scale up for our drawing. Now, the great part about this is that we can use math for a lot of things. I know I've always promised myself not to use math, but it always tends to seep in, especially with drawing with any kind of accuracy. And just as a special note, as I mentioned before, I'm not counting on accuracy. I'm counting on, as far as your grade goes, the knowledge of drawing in 2-point perspective. It could be accurate up to a point. It could be inaccurate, but as long as you have the fundamentals down, that's all I want to see. Okay, so I've measured 76 millimeters to the right edge of the building, and these measurements again will all play a part. So 76 millimeters will be my distance to the right, and 45 to the left, and 123 millimeters to my height. Let's see how all of these measurements will play a part in how to scale up our drawing. Now remember, our final sheet is going to be A4, an A4 sheet of paper. So right now, my photograph isn't really maximized to an A4 size. Now, I could have printed this bigger, but I wouldn't have been able to see the vanishing points more clearly. So if we pretend that this is my A4 sheet of paper, I need to maximize my building dimension so it fits nice and snugly to that A4 sheet. And right now it's 123 by 45 and 76. It's a little too small, so we need to scale that up. So the real question is, how do I scale up my photo reference, my building, to fit an A4 size sheet of paper, keeping in mind always to have that cushion of white space, and in this case, margins. Now these margins won't be as big as we did with our project 1, where we're using thirds to divide our sheet of paper. We're going to use a smaller set of margins. So I'm just drawing a quick little thumbnail, and just to remind you and kind of illustrate, okay, this is what I have currently. I have a small photograph relative to my A4 size sheet of paper. I've done my measurements, and this is what I need to do. I need to maximize that building size relative to that A4 size sheet of paper. And so I'm going to do another little thumbnail that illustrates that scaled up version of the building. as before, my dimensions of my current building, this is what I have, is a height of 123 millimeters and left side of 45 to the baseline and 76 on the right side to the baseline. Now, how do I convert this? What do I have? Well, first I need to know, well, how big is an A4 size sheet of paper? And I had to look this up, but I'll use millimeters for my dimensions since I'm already in millimeters. Let's look that up. So I figured out that an A4 size sheet of paper is 210 millimeters by 297 millimeters. Also, did you think about when doing this, are you thinking about whether you want your piece of paper for your project, either portrait or landscape? There's a reason why I chose landscape. It's because it gives us more room in the width or wide, so we can account for vanishing points and really long, wide shots, which cameras usually capture pretty well. So that's why I chose landscape. We need to also account for the margins or the borders of our sheet of paper. Remember, our white space is very important. Now I'm just kind of gauging here what a good border would be, and I came up with not 20 centimeters, but 20 millimeters. 20 millimeters on each side, top, bottom, left, and right. And that will go all the way around the sheet of paper. Now, I'm gonna draw that border in, but this border on my final project will not be there. It's just kind of an implied border or cushion, white space that we have surrounding that we won't draw anything. For those of you that might think that they might draw something, I suggest using tape, or just make sure you draw in really light lines for your border using one of your H pencils. So we have our dimensions of A4, and now we have our dimensions for our border and what is going to be our workable area, give or take, plus or minus. Well, we need to subtract 40 millimeters from each side. So 297 minus 40 is going to give us 257 in millimeters, and 210 minus 40 is going to give us 170 millimeters. And so this is going to be our workable area, and I'm going to give some cushion to even more, just so we're not even close to that area. You never know what's going to happen whenever you start laying down your lines. So our building can't be larger than this dimension, right? 257 by 170. So 170 is our height, and 257 is our width. And also I wrote down to remind myself that I need some extra cushion just to be safe. Now that we have these dimensions, we need to figure out, well, how big can we go with our building, and by what means are we going to use to increase our building size? We're going to do that in part 3. I'll see you then.